Coming up in Unit 8, we'll be working with graphing, which is an important visual for analyzing data. So let's take a look at each one of these. Tables. We have used tables a lot. We've used tables in math. We've used tables in writing. And we've used charts for all kinds of things. We've used vertical and horizontal tables. You have throughout your school years seen lots of different kinds of graphs. Graphs come as number lines, circles, bar graphs, points, and now on the coordinate plane. The ones that we're going to be focusing on are on the coordinate plane. So equations. Equations are number sentences that have an equal sign. For example, 2 plus 3 is 5. That's an equation. 2 times 3 is 6. That's also an equation. 12 divided by 2 equals 6 is also an equation. On the coordinate plane, we're going to be looking at an equation that looks like this. Y equals mx plus b. That's an equation of a line. We haven't gotten that far yet, but that is also an equation. And as a reminder, x is the independent variable always, and y is the dependent variable. So what are m's and what are b's? B is when the x variable, the independent variable, is 0. And it's also known as the y-intercept. M is the slope of a line, which means how steep or how flat the line is. And if it goes from left to right up or left to right down. So yeah, who cares? Well, as you get older, the premise for the rest of math is this coordinate plane stuff. So higher level math is where things get really interesting. People use higher level math to figure out how far rockets can travel. People use higher level math to figure out how to build things, how high they can go, for example, before the building itself starts to tilt. People use higher level math to figure out angles and grids for drawing or painting things like murals, billboards, and electronic signage. They use higher level math to create new technologies and figure out where and how to put characters or objects in video games, animation, and films. People use higher level math to fix things like motors and electronics. And they also use higher level math to create things like vaccines and cures for diseases. So that's the short list. And so now back to M and B and X and Y. So let's back up with a little bit, and let's start with what we do know. We do know about tables and charts. We also know about ratios. We also know about dependent and independent variables. So this is a table. This is the brownie and batch and egg table. At the top, we have batches. That's the independent variable. Those are the X variables. The eggs, that's the dependent variables. Those are the Y variables. The number of eggs depends on the number of variables that you are making. So if you recall, the independent variable is always the X. The independent variable is the one that you are in control of. You decide how many batches you're going to make. The eggs don't decide on how many batches you make, although that could be a possibility, but we'll get to that later. For example, if you need enough brownies for your class, and each batch makes 12 brownies, and you have 30 kids in your class, you need at least 2 batches, plus enough singles to make 30. So if you can't make a half a batch, you would need to make 3 batches. So then I would look for 3 at the top and find out how many eggs I need. So let's go ahead and take a look back at our batches and eggs. So in the above table, you had 1 batch took 2 eggs. For every 2 batches, you had 4 eggs. For every 3 batches, you had 6 eggs. For every 4 batches, you had 8 eggs. These are all equivalent ratios. So the ratio 1 batch for 2 eggs is the same as 2 batches for 4 eggs, 3 batches for 6 eggs, and 4 batches for 8 eggs. In order to find out how many eggs we need, you can multiply 2, the number of eggs for 1 batch, by each batch. For example, if I have 2 eggs for 1 batch, I know that I need to double that recipe. For 2 batches, I get 4 eggs. If I'm making 3 batches, that's triple the recipe. So I have 6 eggs. If I'm making 4 batches, okay, that gives me 8 eggs. So to create an equation, I can use X for the number of random batches that I need times the number of eggs for 1 batch. So 2 times the random number of batches, which I haven't chosen yet, is going to equal the number of eggs that I will need. So Y is the number of eggs, X is the number of random batches that I haven't decided on yet. 2 is also the number that the eggs increase by for each batch. So we know the word increase means add. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. In addition, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. We can use both multiplication and addition to find the next amount of eggs. So let's take a look at this table. This one looks a little bit different. For every batch, we have 3 eggs. So the ratio of batches to eggs is, you should know that. And then which is the independent variable and which is the dependent variable. The next thing we're going to talk about is common difference. So the common difference is the difference between each batch of eggs. So I have 3 eggs, and then the next batch I have 6 eggs. The difference between 3 and 6 is 3. It's adding 3 each time. That's called a common difference. So now we need to find the equation for any random number of batches. So as in the previous slide, 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times X is going to give me the number of eggs. So let's take a look at something a little bit different. These are differences between sequences. So what I'd like you to do is look and see what the differences are in these 2 tables. The hint says look at the number of batches in the first line of the 2 tables. In the first table, I have 1 batch and 4 eggs. In the second table, I have 2 batches and 3 eggs. Well, what if I only want to make 1 batch? What if I don't want to make 2 batches? Then what am I supposed to do? Think about that for a minute, and then I want you to find the common difference. And I want you to think about what that equation should be. Probably many of you said, okay, I need 1 batch, so I'm going to find the unit rate, the number of eggs for 1 batch. And when you did that, you found that the ratio was 1 to 1.5, which is the same as 2 to 3. In order to find the unit rate, you divided 2 by 2 and you got 1. And you divided 3 by 2 and you got 1.5. Is 1.5 times X equals Y the same as 3 divided by 2 times X equals Y? And do you have to, therefore, find the unit rate? And the next question is, how are these quantities related? The quantities in these tables are related because one depends on the other to start with. They also have something called a linear relationship. I talked about that in the very beginning of this video. A linear relationship means that when the x and the y values are plotted on a graph, they make a line. They always need an independent and they always need a dependent variable. So when you have dependent and independent variables, you often have a linear relationship. The two numbers are ordered pairs, x and y. We are now going to work together on a couple of questions regarding the eggs and batches problems. So find the document titled Questions for Eggs and Batches. And if we're doing this in class, I'm going to give you 7.5 minutes to do the first two, and then you're going to do the rest of it.